We're going to talk a bit about sort of BirdNET and analysing your acoustic data. Really happy to have you all here. Really pleased to get feedback on this and other topics that you would like. We've got a bit of a code of conduct, which Andy mentioned earlier, which is in the next sort of slide. So sort of have a look at that. We just want people to be sort of respectful in terms of their communications and things. And what I'd like to start off with is by acknowledging the traditional owners. So in particular today, I'm coming from the traditional custodians are the Turrbal and Yagara, as the First Nations owners of the lands where QUT is, the lands where Meanjin is, where Brisbane is. We'd like to pay our respects to their elders, laws, customs and creation spirits, and recognise that these have always been places of science, teaching and research, and to acknowledge the important role that Aboriginal and Torres Strait Islander people have always played in terms of conservation and safeguarding the land and sea. Okay, so next slide. So the purpose of this webinar series is to build the ecoacoustics community in Australia, and we've got other events sort of coming, like the Ecoacoustics Symposium in Perth later in the year. And also we've just been informed that we are going to be hosting the International Ecoacoustics Congress in July of 2026. So there's lots of things going on. This is just the latest in our sort of series of ideas about how to sort of communicate and build community, in particular to sort of share and build sort of knowledge and expertise. So this is meant to be interactive. So if you do have sort of any questions, please ask them. If you've got anything to share, then please ask them, but please do so in a respectful way. And so it's really about developing best practice and sort of standards in ecoacoustics. So today we've got three speakers, Filashinsky from QUT, Nina Scarpelli from, well, she was from CSIRO, now Museums Victoria, and Callan Alexander from QUT and BirdLife Australia. And each of the speakers are going to talk a bit about BirdNET, about sort of how it works, tips and tricks, and how to get the best out of BirdNET in order to sort of analyze your sound data to sort of understand who's calling. So we'll have a series of these sort of short talks. I think they're sort of 10 minutes or so, perhaps a bit less sort of each. And then we'll open it up for Q&A and open discussion. And please do let us know if this is useful. We're really keen. We've got a sort of survey at the end. We're really keen to sort of hear your thoughts, to find out if this is useful, if you'd like more of this. If there's not enough time, then we're happy to sort of, run the further sessions to talk more about sort of BirdNET or monitoring protocols or whatever is interesting for you. Okay, so I'd now like to hand over to Phil, Dr. Filashinsky, who's going to lead the first talk about BirdNET.
Okay, so hi everyone, my name is Phil. I work at QUT as a research software engineer. As I was saying, I work research software engineer. I spend most of my time developing recognizers for birds and also creating systems so that I can run those recognizers and other people's recognizers on scale on ecosounds and the Australian acoustic observatory datasets. And that includes creating some software, some adapter scripts for running BirdNET at scale on those systems and making it fit in with our software. So that's where my experience with BirdNET comes from. And what I'll be talking about is what it is from a high level, what are CNNs, what are embeddings, and how that relates to the BirdNET built-in classifier, custom classifiers, and saving and using embeddings outside of, like using them outside of the BirdNET system. So BirdNET is a convolutional neural network, which just like any other machine learning model is a function that maps an input to an output. And it can be thought of as a machine where data goes in one end and some transformations and calculations are done, and then output comes out the other end. And without giving much importance at the moment to what's happening inside the machine, it's just worth noting that there are some parameters which on this picture of the machine or the function are represented by all of these knobs and dials on the front. And in general, in machine learning the not just CNNs, but other things like linear regression, decision trees, random forests, etc. The position of these dials on the machine are learned through observing examples where the output is known, and an algorithm figures out what the positions of all of those knobs and dials so that the inputs match their desired outputs. Now, BirdNet is a convolutional neural network, and in the case of CNNs, if we look inside this machine, we find that it's actually lots of little machines which are chained together and feed into each other. Now, each of these little machines or functions have their own learned parameters, and these blue boxes between each of these steps represent we call them activation maps. And each of those functions has their own little learn parameters. Now, these blue activation maps at each step take the input from the previous step and figure out what's relevant to distinguishing between species and which bits it can ignore, which bits are not relevant or redundant. And eventually it gets to a final activation map and puts that into a different function that takes in the final activation map as an input and outputs predictions. In the case of BirdNet, a prediction for every one of the 6,000 odd species that it's been trained on. So these top set of layers are called convolutional layers, and then that final activation map is called the embedding, and then the final function after that is called the classifier head. And these things all have different names, but that's what we'll stick with for now. Embeddings are a long list of numbers that represent a point in an embedding space, which you can think about like points on a map. This diagram only has 2 dimensions, but the actual embeddings are much higher dimensional, like 1,024 dimensions, which is hard to visualize, so we'll stick with a 2-dimensional map. So the role of the convolutional layers is to take your input spectrograms and position them somewhere on this map, on this embedding space. And then the role of the classifier head is to look at the map and look at where your points are and figure out which class those examples come from based on the position of the map. And the embeddings have been learned by the BirdNet training such that similar call types land in similar positions on the map, which allows the classifier head to do its job. So for example, this unknown example, it could figure out, it's probably more likely to be this orange class than this blue class. So BirdNet has the convolutional layers, an embedding, classifier head, and then the output from the classifier head, the raw output is, or the direct output is what's called logits. Now these are arbitrary size, they can be negative, positive, and they can be used if you want, but most people seem more comfortable with numbers that lie between 0 and 1. So these are transformed into scores between 0 and 1 through a sigmoid function with some influence from a sensitivity parameter, which you can provide. And then you get a score for every one of those 6,000-ish species. And then that set of scores is filtered down to what's actually saved as output by your minimum confidence parameter and a species list, if you provide it. So just a bit more about the transformation between the raw logits and the output scores. This goes through something called a sigmoid function, and you can modify how that's done based on this sensitivity. So increasing the sensitivity effectively increases the logit score before the sigmoid transformation, and that increases the score, which has the effect of sliding this sigmoid left or right. And then the minimum confidence that determines what's actually saved can stay the same, or you can also change that. And these two things influence how many outputs are saved for how many of the species. So BirdNet, as I mentioned, has 6,000 odd species, 6,522 to be exact. And most of these aren't going to be relevant to your particular task because they come from all over the world. So you can prevent irrelevant species from showing up in the results by providing a species list, or BirdNET can generate that species list for you if it's given a latitude and longitude. So how this actually works, previously, it directly looked up an eBird database, and the more recent version of BirdNET uses a trained neural network just for this process that's independent of the actual like BirdNET species classifier, to give a likelihood that the species appears, and then you can give it a threshold of species above a certain likelihood will be included, but that doesn't actually influence the scores. It's just used as a mask between producing scores for everything and then just saving what's of interest to you. So that's the BirdNET built-in classifier head. What you can also do is train a custom classifier. So what that does is take all of the convolutional layers and embeddings just the same as for the built-in classifier, but instead of it passing it through that last function to get predictions, it gets rid of that, makes a brand new function. Oh, sorry, makes a brand new classifier head, and you train that on your own examples. And the number of outputs from that are the number of species that you're interested in. You can see it's got fewer dials on the front because it's a smaller model because of the fewer outputs. So why would you want to do this? It might be that your species of interest isn't one of those 6,000 odd species, especially if it's rare, if it's not a bird, those sort of things. And the other reason is because often you get improved results by giving it data from the region that you're actually analyzing, because of things like species regional variation, or the similarities or differences between confusing species or background noise, that sort of thing. I think Nina and Callan will both talk about that a bit more. And then the other thing you can do is not use a classification head from BirdNET at all, and just save those output embeddings as to use however you like. So you can import them into R or another program, train your own model, do clustering on them. And the reason that is useful and works is because, remember, the embeddings are generated in such a way that similar call types produce similar positions on this map. So that's all I've got time to talk about, and I'll hand it over to the next speaker. Thanks very much.
Cool. So hi everyone, my name is Nina Scarpelli. I'm a postdoctoral fellow at the Museums Victoria, and I used to, just recently I moved jobs, so I'm going to present a bit of work that I did while at CSIRO. And it's just some tips and tricks when using BirdNET custom recognizer and species list. I just want to start by acknowledging the traditional owners of the land where I live, where I work, where my research is conducted, and extend my acknowledgement to other traditional owners across Australia, and pay my respects to elders past, present, and emerging. So I just want to get everyone on the same page. This is not a guide on how to do anything with BirdNET. The goal here is just to showcase some things that I came across when I was doing BirdNET stuff, and that it could influence the recognizer performance and the ecological inference that we do based on those results of BirdNET. So the first work that I did was creating my own recognizer for feral pigs in Far North Queensland, and we were testing the use of acoustics for feral pig detection. So to do that, we deployed camera traps and acoustic sensors together so that I could check if a pig was there, if we could detect them using acoustics. And to prevent, in case we didn't get a lot of pigs around the property, we also deployed sensors on locations where the reserve managers were trapping pigs. So just to make sure that we had enough training data. As predicted, there were not a lot of pigs around, so that meant that I didn't have a lot of training data, and pigs don't make what we call stereotypical calls. What this means is that when you have a bird song or a bird call, you have a sort of pattern. Pigs don't do that. They grunt and squeal as they see fit. So it's really hard to get a pattern for a call that doesn't have a pattern. So this made a little bit of a challenge to create the recognizer. So as I said, initially, I didn't have pigs on all of my sites. I only had pigs on the trapping sites. And hopefully you can see here from this plot. So the plot on the right shows all the detections from initial version of BirdNET that I created for the trapping sites. And on the left, you have the calls, the detections from non-trapping sites. So hopefully, and the green means that it was positive, and the red ones means it was a negative detection. So as you can see here, I created a recognizer that was really good at detecting pigs at traps, and that was not very useful. So what made me realize that the pig behavior and the sounds that they make around the traps are different from the non-trapping sites, even though they were not necessarily inside the trap. So even if they just were going around and eating the feed, the food that was given to them, they were still making different sounds. So what I want to say with this sort of example is that you have to consider where the training data is from, and it's something that Phil mentioned before, that depending the region that you're developing the recognizer for and the species behavior that you want to capture with your recognizer, you have to make sure that the training data is matching what you want as a result and what you get in a natural environment. So it's just something to be aware of. So to try and enhance the training data that I had, I used some very low confidence scores, and I manually validated a lot of detections. So again, if you see on this plot here on the left, on the low confidence, I had some pigs outside of the traps. They were just hidden. So I had to manually validate these detections to be able to find them. So what I want to say here is that don't be scared of the data. Don't fear interacting with the data, because it's really important to understand what's going on and get to know how your recognizer is working, what's the output actually being from the inputs that you gave. Another example from this, in the same property in Yorka, we were having lots of detections from the BirdNET off the shelf. Even using a custom species list, we were getting detections of pelicans, and we never saw pelicans there. So when we went to look at what was happening, every time that there was water splashing, BirdNET was thinking that it was a pelican, probably because from BirdNET training data, every time that there is a pelican, there is water splashing. So the model learned that pelican equals water splashing, which is not true. So just go and check the results and make sure that what you're inputting is what you're getting. What you want as an output is what you're getting. The other thing that I did was to include species that the recognizer was getting confused with. So I was getting koalas mixed up with pigs. The recognizer thought that a koala call was actually a pig. So even though for this work I didn't care about koalas, I didn't want to know where they were, I included them as a class of my recognizer, and that improved the results, because then the model learned, oh, this is a pig and this is a koala, so it was better at distinguishing the two classes that it was getting confused with. Regarding the amount of training data that you need, it's going to depend on the type of species, the type of environment, lots of different things. As like a general rule, what I found in my work was that those stereotypical calls, so calls that have a pattern, need less training data than calls that don't have a pattern. So for example, with the koalas, I only needed like 39 calls to 39 3-second segments to get a good recognizer. Cane toads, same amount, like 35, noisy minus even less. With 5 calls only, I was able to get pretty good results. But then for the pigs, I needed 119. So it's gonna depend on the species, the behavior, and the types of calls that you have. Another way of enhancing the training data is to use the A2O search. So you can I put some of my calls from pigs on the search tool, and then I was able to find calls from completely different locations, pig calls from different locations that I could put on my recognizer. And I know this may seem a bit counterintuitive with what I said before, that you have to have training data from the locations and what you want to detect, but at the same time, it's really easy to overfit these models. So this means that what you're going to find is only the data that you was trained for. Your recognizer is going to be really good at recognizing the pigs in Yorker at those sites that I trained for. And one way for preventing this is to using calls from different locations, and the A2O search can help with that. When it comes to training the recognizer, I had many versions, and I was just running the recognizer and getting more and more training data. Some very smart people came up with better, faster ways to do that. So have a look on those papers, and those use the embeddings that Phil was saying before. But yeah, I didn't know about this before, so I had like 30+ versions of the recognizer, and I guess it's really important to keep track of the versions and the training data that you use for each version and the recognizer output, because then it's easy to know what you did from one version to the other to make it better or worse, and it's also easier to go back. So if your new version is worse than the previous version, you can always go back to a better version. So it's good to keep track of things. When it comes to choosing the best recognizer, there are different ways that you can do this. There are lots of metrics that you can use to select the best recognizer. So recall and precision are some of these metrics that are used in machine learning. In my case, I had some versions that were better for precision and some versions that were better for recall. And so I guess sometimes you cannot choose just one single best. And there are like little questions or little things that you can think about to see which of these metrics better represents or better helps you to answer the question that you're asking. So things like, do I need to detect the species every time that it's present, or I'm just worried about presence absence, and what is the resolution of the presence absence? Do I need one presence per site, one presence per day, one presence per hour? And this is all gonna influence what type of these metrics that you choose to then select the best model. Combining the models and the results can also be a solution, especially if there are different behaviors on your training data or on the species that you're trying to detect. In my case, pigs had a different behavior during the dry season and during the wet season, and that's why I had a better precision recognizer, was detecting pigs better on the dry, and better recall was better on the wet. So combining the results can be a solution as well. You can use confidence scores to filter the false positives, but you need some stats to back it up. And yeah, have a look on those papers as well and make sure that you understand what the scores are doing so that you use them appropriately. And I guess just some other technical considerations when using the species list. This was another project that we were detecting babblers in Baura. And the first thing when you're using species list is to make sure that the species that you're looking for is on the BirdNET species list. Check the spelling, even for the common names. UK and US spelling can be different, and that's gonna make your recognizer not detecting the species if you misspell even the common names. And the character encoding. So if you can see here, this Hall's babbler, the inverted comma is different than this one, and for the recognizer, it makes a difference. So the best way to prevent that is to copy and paste the names from BirdNET list on your species list, just to be safe. So just to finalize, be aware of the model's biases and the technical issues that can influence the results, because using the appropriate spatial temporal resolution for your detections is gonna make you have a good result, and that's gonna help you with having good ecological inference based on the results that you're getting from the model. Thank you.
Fantastic. Thank you very much, Nina.
Yeah, hello everyone. My name's Callan. I'm hopefully nearing the end of a PhD at QUT, and I also do some work for BirdLife Australia on a bunch of different acoustics projects. And yeah, I'm just going to share some things that I found useful when working with BirdNET, and hopefully they are useful for you also. Yeah, so Nina and Phil have explained thresholds and confidence scores really, really well. But I guess I just wanted to note that, especially when you're using multi-class recognizers like the ones that sort of come with BirdNET out of the box, it's the key thing to understand is that the optimal confidence score threshold is going to be completely different for each species. So confidence scores are not comparable between species. And so there's going to be an optimal confidence score for each species. And that's the place where you'll have the best balance between precision and recall, or your best F1 score. So you can see, I don't know if you can see my mouse, but the red there, that species, the best threshold for it will be at 0.15, and another species, the best threshold might be at 0.5, and some might be all the way up at 0.95. So it just, confidence scores are not transferable between species. So you do have to think about that when you're sort of using BirdNET. And so what you can do is you can tune your thresholds. So it's pretty common just to set a blanket threshold and then just look at everything above that, like 0.8 is quite common. Perfectly fine for some projects, depending on what you're doing. But I think for a lot of projects, it's really important to understand what is happening underneath your threshold or across all thresholds. So for example, in this figure here, it shows, and again, I don't know if you can see my mouse, but the blue line is true positives at a bunch of different confidence thresholds, and the red line is false positives at a bunch of different confidence thresholds. So if you set your confidence to 0.8 for that particular model or species, that's great. You'll have a low amount of false positives, but you might have been better off just setting it a bit lower, get a lot more detections, and still have a relatively manageable amount of false positives. And when you're dealing with lots of species, there's a few potential approaches for threshold tuning. One of the easiest ones to implement is just a precision target, where you're like, okay, I want high precision for all my species, so I'm just going to validate until I know that this is the threshold where I'm getting a precision of 0.9 or 0.99 or whatever it is that you want. But you do then have to understand that your recall is going to be very different at those different precision scores for different species. You can calculate the optimal threshold for every single species. It's quite time intensive because you need a test data set where you can also investigate recall. And then I highly recommend that you read this All Thresholds Barred paper, which talks about breaking your detection into confidence bins. So a bin like 0.0 to 0.1, 0.2, 0.3. So yeah, I've been doing that. So I will run my models at the lowest possible threshold and try and look at everything wherever I can. And yeah, so using BirdNET for species lists. I think Nina's touched on this, and I think most people who have used BirdNET will have seen this, but highly inadvisable to rely on BirdNET for a species list without some level of expert validation. And by that, I mean setting the latitude and longitude and then just taking the species that it says at face value. Definitely get an expert to go through your data if you can. This plot over here shows a fairly large acoustic data set, but BirdNET just run over it and how many species it would say was present at different confidence thresholds. So even at a very high confidence score compared to how many species are actually there when we validated it, it overestimates species richness a bit. So yeah, get someone to look at it before you rely on those species lists. A good way to start is to sort of look at the species that have the lowest number of detections and then look at the highest confidence of those detections. But the tricky thing arises is that often confidence score patterns may not be consistent. So for some species, the most confident detections might be false positives, and there'll be true positives hiding somewhere in the middle in like 0.4, 0.5. So that throws a bit of a spanner in the works. And I'll talk a little bit about that later. For those of you who are like me, excuse me, who are doing a lot of validation. So validation involves working with the sound segments that BirdNET spits out. You can use BirdNET to generate those segments directly, or you can use a script from a selection table, whatever works for you. There's lots of really good validation interfaces popping up now. BirdNET has one inbuilt, EcoSounds has one, there's an interface within Raven. My preference still for large-scale validation is actually just still to use the default interface in Raven. And what I like to do is I like to drag in thousands of segments at once. And for those people who use Raven, my favorite discovery ever was this choose measurements begin file. And what that does is in each of your selection tables, it adds the file name that you annotate. So for example, this here is a couple thousand eastern bristlebird detections dragged in. And most of those detections are bristlebirds. I don't want to manually label every single true positive bristlebird because that's going to take me forever. And I can usually tell just by looking at it if it is or isn't a bristlebird. But every now and then a mistletoe bird pops up, a brown thornbill pops up, a rufous shrike thrush, and I do want to label those false positives. So what I can do is I can just annotate the false positives. It will include the file name in my annotation column. And then I have a little script. If anyone wants it, just email me. I have a little script that will then filter. It will pull out all the false positives, and then I'll just have all my true positives in one folder and my false positives in another. And yeah, that's how I like to do validation at scale. If anyone has any better methods, would love to know. Yeah, so Phil did an awesome job of explaining embeddings. I wish I'd seen that talk a few years ago, Phil, because it took me a long time to wrap my head around what an embedding was. But this is what an embedding actually looks like when you can generate them in the BirdNET GUI now, which is really nice. You don't have to script them. But why are embeddings useful? Phil sort of hinted at some of this, but the models like BirdNET and Perch are particularly useful for bioacoustics tasks. And if you read that Garni et al. Paper, it explains why a lot better than I can. But yeah, the embeddings generated by BirdNET and Perch are really great for clustering or few-shot learning, so training a custom classifier on a small number of examples, or similarity searches like the acoustic observatory. And I like to use embeddings for clustering in particular. The BirdNET and Perch embeddings, there's quite a few people using them for this. They're great for grouping similar sounds together. I like to use UMAP combined with HDB scan because HDB scan is really good at throwing out noise points that you may not be interested in. And I like to use clustering as sort of a post hoc test to search across all the models, all the thresholds of a model. Particularly for species where I think it should be there, but maybe BirdNet's not finding it, or the models are not finding it, or we have a lot of false positives. I won't go into too much detail because I'm probably running out of time, but the methodology is in this paper. In that paper, I use acoustic features rather than embeddings, but the method is kind of the same. It's a good way also to find training data to build your custom models. And so in a nutshell, basically clustering can sometimes find the true positives and false positives better than your model can. So here, for example, the clustering process, the pink and the brown, everything that's circled is mostly true positives, and it's split out all of the false positives. And it's outperformed the optimal threshold for that particular model, which is nice. And then you can go and collect all your true positives and use them for training data. It's a bit confusing. So in practice, this is a common minor from BirdNET run over a very large data set. And when I was validating, I couldn't find any particular pattern in the confidence score. So there were a lot of false positives at high confidence, true positives at low confidence, didn't know what was going on. So for those who aren't familiar with this sort of plot, every single point here is 3 seconds of audio. And I've colored it by confidence score. And you can see that there's not really any pattern. And so that there's no pattern in the confidence scores in what's going on there. But when I throw HDB scan over it, it splits out all of the common minor, or almost all of the common minor vocalizations on the right, and it throws out all of the rubbish on the left. And I use a little tool. Other people have similar tools. There's a draft version of it in that call the PowerFile paper. But you can click on points, and then you can sort of inspect your clusters. And so, yeah, all the common minors are on the right, and it's thrown all the nonsense out to the left. And that's really great for then collecting training data and building new classifiers. I'm running out of time, but yeah, the same thing happened with Eastern Barn Owl. We had thousands of detections, even at high confidence scores, mostly false positives, and it threw all of the actual barn owl calls into cluster 8, and then we could build a custom classifier. Well, yeah, skip through that. But yeah, in conclusion, BirdNet's super useful. Common species work incredibly well out of the box. Please manually validate your data, and yeah, good to understand what's happening underneath your thresholds. Happy to chat anytime. Thanks.
Thanks for the presentations, everyone. We've got a few questions in the chat. We might, and we also had a few questions submitted in the registration process. If we don't get through all the questions, we'll answer them via email after the session. But we have one here from Joseph Janke. Hello, I'm wondering whether people who have been using BirdNET to create custom classifiers for bird species not included in the original dataset have had trouble processing their data into the exact input expected by the model. Is there somewhere to find the exact parameters for the metaspectrograms the model expects?
I think the model expects just 3-second wave files. Well, yeah, I'm pretty sure. So I'm not sure, like, what do you mean about the parameters of the MEL spectrograms? I don't know if you can manually change those things, but yeah, the model only wants you to chop recordings into 3-second segments that contain your target call, and there are ways on that you can select which bit of your 3 seconds. So if you are a bit over the 3 seconds, it can chop from the beginning of the 3 seconds, or the middle, or the end. So there are some of these things that you can select on BirdNet, but it's only like 3-second wave files that it takes as an input.
Yeah, I think that's right. The conversion to the spectrogram, as far as I know, is actually done inside a TensorFlow layer by TensorFlow.
Yeah.
So first it resamples everything to 48 kilohertz, and then converts it to a spectrogram representation before feeding it into the first layer of the convolutional network, from my understanding.
Thanks.
We have another question here from Daniel. I'm trialing a bird weather device that uses BirdNet. Has anyone got any feedback on these devices? I guess that's a general question for probably everyone.
Yeah. I know some people that have used, and I guess it's going to be, because it's the BirdNet model, it's going to be BirdNet off the shelf that it's going to work under. So I guess, Callan, do you have anything to say about BirdNet off the shelf?
I haven't used them personally, but yeah, I would imagine that relying on them without validation is going to be the same as relying on BirdNet without validation. So there's probably going to be a lot of species that it says are there that aren't actually there, would be my guess.
Yeah, it's probably works well for common species, like you said, and then yeah, just gonna have some weird things in there.
Thank you. And Gregory was happy with your explanation, Philip. It's the best he's heard or seen anywhere, which is
I should actually probably mention that was inspired a little bit by a talk from Vincent Dumont from Google DeepMind. We did a workshop together last year, and he decided to use the metaphor of the treasure map.
Now, Rupert, did you want to ask your question?
Yeah, hi, thank you. Great presentations. I'm really just confused about when we're making individual species classifiers, embeddings, how we can join those together with other embeddings if we can at all. And if you need a single model that's trained on, like in the typed example, if you include the koalas as a null sample, then it'll set pigs to 0. But I'm confused about how we could combine custom embeddings or the core model to, is that even possible?
Yeah, so with the koalas and the pigs, for example, what I ended up with, I was just interested in the pigs, but I ended up with a multi-species model. So when you're doing that, the way it works, you can you set up your folders with the training data, those wave files that we were talking about before, the 3-second wave files. So I had one for pigs, one for koalas, one for the cane toads, and one for whatever else, noisy miners and stuff. And now I think when you're doing that with BirdNET, you can have a folder, for example, for pigs, and then one folder for minus pigs. So you can tell it what is not a pig, but it can include examples of your other species. And then you can also have a folder with noise that it just includes everything else. I don't know, crickets, let's say that it's thinking it's crickets, so you just put it in there. So that's how you set up the folders. There is a good video from the BirdNET team that tells you how to set up, how to build the classifiers and how to set up the folders. And when I was doing my stuff, that's what I used. And with the embeddings, I think you use the embeddings to do the search and get more of the training data. And then I think if you want to build your own classifier, then you use those, not the embeddings itself, but those embeddings correspond to a timestamp on your audio file. And then you use that timestamp as in your training data to build your own recognizer. So it's a bit of a 2-step sort of process. I think that's how it works as far as I understand.
And so if everybody in the audience today was to potter off and create a single recognizer for a single species that hasn't been classified yet, could we bring those all back together and run them as a single model, or would we be running them stepwise?
I don't think you can put them together. I think what we could do is everyone just brings their training data together and we build a classifier with the training data from everyone. I don't think we can combine the TensorFlow. Maybe Phil will know better.
I'm not that sure. I don't have much experience building the custom classifiers, but I think what Nina said is correct. Yeah. So to sort of pool efforts, a lot of the effort is going into the building a good set of data for your species, and then the training is sort of easy once you've got that nice data set. During the process of training, you'll probably end up adding more examples to improve it little by little. So you put your own effort into that part of it, and then the effort or the real valuable thing out of that is that set of examples that work really well to make a good model for your species. And then, yeah, a way to pool efforts from that would be to pool the training data. So you have good examples and and then just train it from scratch using that training data. That's what I feel anyway. But again, there are regional differences and things like that. So yeah, if it comes from all over the place, it might not work as well sort of somewhere else as it does for where you've actually put that effort into building that training set.
So perhaps as a
Label set, I should say.
perhaps as a crowdsourcing exercise, it's more valuable to pull the snips, the 3-second WAV files than it is. Yeah, cool. Thank you.
I might have time to get through one more. Mike or Honey, did you want to? Were your questions answered?
Well, I suppose my question has been answered. Yes, it's just a question about the number of calls you would need to be able to train a recognizer. As Sebastian said, like in some cases, it can be just a very small number of calls. And I think Anina used that for the noisy miner as a small number. Very distinctive, whereas some more, a bird that sounds like every other bird, like distinguishing rosellas or something like that, it might be much harder. And thank you for the link, Sebastian.
Yeah, I think it's going to depend a lot on the species and the types of calls that you're looking for. I suspect, I don't know because I didn't have lots of birds on my classifier, but birds could be easier just because BirdNET has been heavily trained on birds, and those things that I was mentioning with the stereotypical calls. Again, I don't know how it would work if you have a species that mimics other species and all those things. So it's going to depend a lot, I think. But I think for birds, you probably don't need a lot. And then, the further away you go from the birds, probably harder, I think.
I've just got one question. Someone didn't get to it. It's just, is there worth doing any pre-processing of audio files? Like there's options to run it at different speeds and things like that in BirdNET, or is it worth switching to mono and normalizing it somehow? Has anyone tried that, or is it worth doing?
I haven't tried to play around with the speed and stuff like this. I did play mostly with the confidence, like I said. I just put the confidence really low to try and get more examples, but I guess with embeddings, you don't need to do that anymore. But I haven't played with those settings, so I'm not really sure. Sorry.
I just had one other question as well. With the issue with the pelicans, like detecting water splashing, like in training, because some of the data we're picking up species during high water events when there's a lot of echoes on the water and stuff like that. I'm just wondering if we use our locational data and seasonal data of those birds, has anyone had issue with echoes and things like that? Is that the kind of thing that messes up training and stuff? So I don't want to sort of just detect, okay, that's another high water event because there's echoes across a lot of water.
Yeah, I don't know. It's a bit like what Callan was saying, that you have to have some validation.
Yep.
So the manual validation, it's a really important step if you're using just the off the shelf, and that will tell you if I think for a lot of water birds that seem to happen, if you have water splashing, lots of water birds get detected where they shouldn't be.
Yeah.
But that's that's a bit of a gut feeling type of guess. Like I haven't measured that, so
Thanks.
Callan, do you have any?
I think that's right. But if you're building your own classifiers and all of your training data has water in it, or all of your training data has a particular insect in the background, and then you try and run that on a site where there's not that insect or there's no water, sometimes it will generalize okay, and other times it won't. It's really the only way to figure that out is to test it on your own specific circumstances.
Is frequency filtering worth it for that sort of thing? Does anyone, or is it too time prohibitive?
Depends on your species and what your like I find for nocturnal, sometimes frequency filtering can be good if it's like owls and you're looking right in the very low frequencies.
Yeah.
But again, you probably won't know if it's worth it until you've tested it in your own particular circumstances.
Yeah.
So we've reached time, unfortunately. We could have probably gone for another half an hour. There's so many great questions. We didn't get to everything. If people are interested in a longer session or a conversation on analysis or more details, let us know. It'd be great to get your feedback in this survey and to understand, topics that you'd like to hear about. So if you could just take 1 minute, say now, to just fill in that, it will really only take a minute. And while you're doing that, I want to let you know about the Open Acoustics workshop that will be happening the 17th of November in Perth. That's hot off the press. We've just opened up registrations for that. So it would be great to see some people there. It should be a great session. There's more information there. There's also a few other upcoming events. We've got International Data Week coming up, conference in Brisbane. We've got Ecoacoustics 2025 and AOC as well. And feel free to sign up for the Planet Research Data Commons. You'll get lots of useful information, tips and tools, and happenings on what is going on in the world of the planet and ecology. So we just want to thank everyone. We want to thank our speakers for today and the great tips and tricks and information they've been able to provide. And we hope to see you for the next. This is the second in the third of our series. And we should have another session in September. I might pass it over to Paul to close.
Thanks, everyone. It's been really great. Thanks to all of our speakers. You're absolutely wonderful. Please do fill out that survey. We're really keen to get your feedback. We're happy to, if people want, we can run a sort of a follow-up BirdNET webinar. And we've also got the sort of the physical face-to-face sort of event in sort of Perth. So yeah, thanks everyone for attending. Please give us feedback. Let us know if you want more of these, what we can improve and what you like. So thanks everyone. Have a wonderful afternoon.